A warm welcome to all of you in this lecture on extrusion of plastics. We are covering a series of lectures on processing of plastics in module number 4 for our course on processing of non-metals. We have already discussed two important aspects related to the plastics. In lecture number 1, we have seen what are thermosets and thermoplastics. We have seen the advantages and limitations of plastics. We have seen what are the various application areas of thermosets, what are the various application areas of thermoplastics, and we have tried to understand the basic difference between the two categories of plastics, that is thermosets and thermoplastics. In lecture number 2, if you remember, we have seen that what are the various mechanical properties that are important in case of plastics. We have seen the stress strain behavior of a thermoplastic. We have seen how a plastic fails under the fatigue loading, and we have discussed one of the important processes or one of the simplest processes for making plastic products, and the process was casting. We have also seen in our previous lecture that there are three important words which we should always keep in mind when we are discussing the processing of plastics, that is the heating, forming and cooling. I have given them H, F and C words or H, F and C alphabets. So, H, F and C means heating, forming and cooling. If you remember, in casting we had only two infrastructural requirements, that was to melt the plastic and to pour that molten plastic into a mold. So, there were two requirements, one was an equipment required to melt the plastic and the other one was a mold that was exactly duplicate of or exactly replica of the final product that we want to make. So, basically in case of casting we need temperature, the heating is being done of the plastic, that is H, and then we are forming it, that is giving it shape with the help of a mold, that is forming, and finally when the plastic is there in the mold we allow it to cool, that is cooling process. So, all the processing techniques that we would be discussing for processing of plastics would be having all these three types of steps or all these three steps one after the other. So, today our topic is extrusion, and extrusion word most of you might have already heard. In case of metals also extrusion is done. What are the different types of extrusion processes? That is a forward or the direct extrusion, backward or the indirect extrusion, hydrostatic extrusion, impact extrusion. So, extrusion is not a new word, but extrusion of plastics is done in a slightly different way as compared to the extrusion of metals. We have already, we can say, discussed that we have to heat the plastic, we have to form the plastic into the desired shape, and finally we have to cool it. So, these three steps would be similar in case of extrusion of plastics also, but the process would be different from that is done for the metals. So, in today's lecture we would be focusing on the extrusion process. Then extrusion has got some variants also, that is depending upon the specific requirement we may go for co-extrusion, or sometime it may be used for jacketing a plastic material over a wire. So, we will see and try to understand with the help of diagrams that what are the various process variants of extrusion specifically in case of plastic materials, and we would not be discussing or highlighting the issues and challenges that are there in extrusion of metals, because our course is focusing on extrusion of non-metals, and right now we are focusing on module number 4, that is processing of plastics. So, today we would be covering the extrusion process specifically in context of the plastic materials. So, let us start our discussion with this introduction. Now, what is extrusion? Although we will try to understand it with the help of a diagram also, but what is extrusion? Extrusion is a high volume processing method. If you remember in the last lecture on processing of plastics, there were two important points that were highlighted related to the processing. That is that the processing technique for a plastic can be a continuous technique in which the product is coming out continuously, or it can be a repetitive cyclic type of processing in which we may say 100 components per hour or 500 components in a day. So, that is a discrete type of production in which number of parts are being produced, and processing of each part basically means one cycle. So, there can be 500 cycles of processing in a day or maybe 5000 cycles of processing in a day, but extrusion process is a high volume processing method and it is a continuous processing method. Once the process has been started, the raw material can be fed continuously and the output that we are going to get would also be a continuous output. Now, depending upon the length or the size of the final job required or the final product required, we may have a cutting arrangement which may be automatically cutting the final product into the desired lengths. So, extrusion process is a high volume processing method, production rates are very high. Plastic material is melted with the application of heat and extruded through the die into the desired shape. So, the extrusion process we will see the diagram also, but here also the raw material is in the form of a plastic, it is melted and it is extruded, means it is pushed through the die and the final product would be depending upon, or the shape of the final product would be depending upon the shape of the die. For example, that if we want a circular cross section final product, the opening in the die would also be circular. So, whatever is the shape of the die opening, similar type of product or the cross section we would be getting. Just to give you an example of extrusion, whenever we press a toothpaste, through the opening the paste comes out. So, what basically we are doing, we have a raw material inside the toothpaste and we are applying the pressure on that tube and through the round opening the toothpaste is coming out. Similarly, here also in the barrel we will be having the raw material which will be in the molten stage and we would be applying pressure and the molten plastic would be coming out of the die opening depending upon the cross section of the die. So, the important point to note here is that extrusion we are applying certain pressure also, but if you remember the previous process that we have covered in the last class, that was on casting. In casting, the material was, or the plastic was being melted and it was being poured into the mold cavity and no pressure was being applied. The material was allowed to cool to take the desired shape of the mold, but here in case of extrusion we are applying the pressure also. So, the second point on your screen clearly identifies the difference, that here the pressure is also applied, that is plastic material is melted with the help of the application of heat and extruded through the die into the desired shape, and extrusion means there is a pressure which is also being applied. A cylindrical rotating screw is placed inside the barrel which forces out the molten plastic material through a die. So, this pressure is here is being applied with the help of a rotating screw. So, it is a screw type of extrusion process. We can have other types of extrusion processes also in which we can use a piston and a cylinder type of arrangement to exercise or to subject pressure on the molten plastic so that the plastic comes out of the die opening. But here on your screen one of the common types of extruders are the screw extruders, in which the rotating screw is placed inside the barrel, the screw is rotated which forces out the molten plastic material through the die opening. Again I am emphasizing the shape of the final product would be dependent upon or would be depending upon the cross section of the die opening. Now, on your screen we see a very simple diagram of the extrusion process. We can see, let us first see what are the important elements in this diagram. We have the heaters, these are the heating arrangements or heating elements all around the periphery of the barrel. These are the heating arrangement, this is the barrel. hatched portion is the barrel, and then this is the rotating screw. The direction of rotation is also shown, it is marked by an arrow, rotating screw. This is the rotating screw. We have the heating arrangement, we have the barrel, a rotating screw, and these are the cooling rolls which are used to cool the final product. The final product is the red portion on your screen. It is coming out continuously. This is the die opening. On your screen you can see this is the die opening from where the molten plastic is coming out and taking the shape depending upon the cross section of the die opening, and this is the hopper. These small particles, or we can say raw materials, are in the form of pellets. So this is the raw material, this is the hopper through which the raw material is entering the barrel, and inside the barrel the temperature is high. Why? Because of these heating elements or heating arrangement. So in this diagram we have seen what are the various elements, and now we can try to understand the role. The raw material is placed in the hopper, the raw material enters the barrel through the hopper continuously, and this rotating screw is rotating it. The raw material after entering the barrel will get heated because of the heating elements, and these heating elements will melt the plastic material, and this molten plastic would be pushed by this rotating screw, or this is the example of a screw type of a feeder. This would be feeding the molten plastic to the die opening, and this die opening will correspond to the final shape of the product, and the final product on your screen is coming out. Now since the molten plastic would be at an elevated temperature, we would be requiring a cooling roll to cool the molten plastic. So basically here also the three stages are common. Stage number 1 is the heating, in which the raw material which is coming from the pellets is entering into the barrel. Because of the heating elements, the raw material will get heated and melted. So first stage is heating and melting. Second stage is forming. This is being pushed by the screw feeder into the die, and the forming of the final product is taking place in the die. That shape of the final product will depend upon the shape of the die opening. So that is the forming process, and finally the cooling is taking place with the help of cooling rolls, and the heated plastic is getting the final shape, and the cooling process is taking place after that. So the three stages step by step are heating of the molten plastic, heating of the plastic pellets, or the raw material pellets are available in the solid form. So heating of the solid pellets, melting of the pellets. Third stage is forming of the plastic into the desired shape at the die opening, and finally the cooling of the final product which has been made or processed by the screw type of extrusion process which is shown on the screen. Now whatever diagram we have seen, we will try to see the various steps involved. Although I have explained twice that how the process actually takes place, but again we will try to read and understand what are the finer points in this extrusion process, in which plastic in the form of a pellet form is getting converted into a final product. The final product is coming out continuously out of the die opening. So the plastic material in the form of pellets or granules. Pellets or granules means the raw material is in the solid form. So plastic material in the form of pellets or granules is gravity fed from a top mounted hopper into the barrel of the extruder. So there are 3-4 important terms which, if you have no idea about the extrusion process, again I am emphasizing. Pellets or granules is the raw material which is available in the market. So the raw material is in the form of pellets or granules. This is gravity fed, which means there is no pushing of the raw material. The raw material is fed under gravity from the vertical hopper. In the hopper the raw material is put, and from there it comes down by gravity into the barrel. Now barrel is the part which is heated because of the heating elements provided on the circumference or the periphery of the barrel. So barrel is the heated zone where the temperatures are high, because the plastics are being entered or the pellets are being entered from the hopper into the barrel. The pellets would melt and they would form a molten plastic material, and then this molten plastic material is fed towards the die with the help of an rotating type of screw in case of screw extruders or screw extruders. So, the barrel of the extruder is fed by the pellets from the hopper, that is the summary of the point number 1. Additives such as colorants and ultraviolet inhibitors can be mixed in the hopper. Now we want the final product, as in our diagram we have seen the final product that was coming out of the extrusion process or the extruder was red in color. Now suppose we want to give a different color to the final product, the colorants would be added in the hopper stage only or in the with the raw material only, and sometimes the final product may be required to operate under specific set of operating environments. So therefore in those cases also we may need to add certain additives into the raw material so that the final product exhibit those properties for which the raw material has been blended. So basically additives such as colorants and ultraviolet inhibitors, these are some examples. Ultraviolet inhibitors, there can be other type of reagents or other type of additives which may be blended with the basic raw material or basic raw plastics, and these are mixed with the raw plastic in the form of pellets in the hopper only. So additives such as colorants and ultraviolet inhibitors can be mixed in the hopper. Point number 3. Plastic materials enter through the feed throat and comes into the contact with the rotating screw. So this is another term is coming into this particular point, that is the feed throat. Feed throat is the point through which the raw material in the form of pellets would be entering the barrel. So through the feed throat the pellets would be entering into the barrel and would be coming in direct contact with the rotating screw. Now what is the role of the rotating screw? The role of the rotating screw is to perform the uniform melting and the uniform feeding of the raw material towards the die. So the heating is being done by the elements which are provided all around the barrel. Now plastic material enters through the feed throat and comes into direct contact with the rotating screw. So the raw material has entered into the system. Now the rotating screw pushes the plastic beads forward into the barrel. So the barrel has got a definite length, and the place where the raw material is entering, the rotating screw pushes this material forward towards the die. So the rotating screw pushes the plastic beads forward into the barrel, which is heated by using the heating elements. Now the barrel is already heated with the help of heating elements up to the melting temperature of the plastic. So we are heating it to a particular level, and the level is higher than the melting temperature of the plastic. Now the plastic which we have entered in the form of a solid, which is further in the form of a pellet. So the raw material that is entering is a pellet which is solid, and now this pellet or the number of pellets or thousands of pellets are melting because of the high temperature generated inside the barrel because of the heating element. So the melting of the plastic takes place, or the plastic pellets takes place. There are 3 possible zones in the rotating screw, that is, now the rotating screw will also have got its length. Now in that particular length we can have different zones like the feed zone, the melting zone and the metering zone. So basically feed zone, the role of the screw and the feed zone is to feed the material in the barrel towards the die. Second is the melting zone. Now in this particular zone the actual melting of the plastic would take place, or the plastic pellets would take place because of the heat generated because of the presence of heating elements around the periphery of the barrel. And finally metering zone means that a definite amount of material would be metered which would be coming out of the die. So 3 important zones are there. Feed zone, role is feeding the material. Melting zone, where the actual melting of the pellets is taking place because of the heat generated due to the heating elements outside the barrel, present outside the barrel. And finally the metering zone, where we are predetermining that what amount of material should come out in one particular shot. Although it is a continuous process, but still the metering has to be done so that exact amount of the molten plastic flows towards the die. The plastic material is completely melted in the melting zone, which is very important in order to make products by the extrusion process. A thermostat is used to maintain the inside temperature of the barrel. The overheating of the plastic should be minimized, which may cause degradation in the material property, which is very obvious that if we raise the temperature beyond the particular level, the properties of the material, that is the material in our lecture today is a plastic material. So, the properties of the plastics will get degraded because of the high temperature to which they are subjected to. So, we have to decide that up to what temperature the heating process should take place, or what is the melting point or melting temperature for that particular plastic at which it will melt and can be formed into the desired shape. So, for that purpose, to exactly know that what is the temperature inside the barrel, a thermostat is used to maintain the inside temperature of the barrel, and we have to avoid the overheating in any case because it would affect the final properties of the extruded product which is being made by the extrusion process. Now, at the front of the barrel, the molten plastic leaves the screw and travels through a screen pack to remove any contaminants in the molten plastic. Now, these are some additional features which are provided in the extrusion process. Although the basic mechanism is, or the basic process is can be divided into 3 stages, in which initially the raw material is being fed from the hopper into the barrel. The barrel has high temperature because of the heating element. In the barrel, the material or the plastic material melts, and because of this melting action, it is pushed by the rotating screw towards the die. The molten plastic comes out of the die and takes the shape of the die to get the desired final product on the continuous scale or in a continuous manner. But there are few additional attachments also which are provided in order to further improve the effectiveness and efficiency of the process, which are mentioned on your screen now. At the front of the barrel, there is another, we can say, thing which is present, that is the molten plastic leaves the screw and travels through a screen pack to remove any contaminants in the molten plastic. So, we are manipulating our raw material so that there are no contaminants present in the raw material which would subsequently affect the properties of the final product, and therefore a screen pack is used to arrest all those impurities or contaminants. The screens are reinforced by breaker plate. What is the role of the breaker plate? The breaker plate assembly also serves to create back pressure in the barrel. So, we need to create a back pressure in the barrel. Why the back pressure is important, that we would be seeing in the subsequent point. The back pressure gives uniform melting and proper mixing of the molten plastic material in the barrel. Now, if you see in the previous slide, we have seen that sometime colorants and some ultraviolet inhibitors or some other types of additives have to be added with the plastic pellet, so that we are able to improve the properties, or we are able to define the properties of the final product depending upon the specific requirements. But where will this mixing be taking place? Because in the hopper, all the colorants, the pigments and the pellets are present in the solid form. So, this mixing up has to be taking place in the barrel. So, this back pressure provided by the breaker plate, that is there in point number 2, helps in the uniform melting and the proper mixing of the molten plastic material. That is, this particular melting is being taking place inside the barrel. Now, back pressure will help, or it would further catalyze the uniform mixing and the heating process. So, uniform heating and uniform mixing of the various constituents that have to go into the final product is better if we are able to generate a back pressure. Now, the screens are reinforced by a breaker plate. The breaker plate assembly also serves to create the back pressure in the barrel. The back pressure gives uniform melting and proper mixing of the molten plastic material in the barrel. After passing through the breaker plate, molten plastic enter into the die. Now, the final stage is where the material has to be formed. Till now, whatever we have discussed, our focus was primarily on the melting of the plastic and raising the temperature of the pellets to a temperature higher than the melting point of the particular plastic. So, the raw material has come from the hopper, it is gravity fed into the barrel, and inside the barrel there is a feed, inside the barrel there is a feeding zone, there is another zone which is called the melting zone, and finally the metering zone. So in the melting zone the actual melting of the plastic is taking place, and a uniform mixing of the various constituents is taking place during the melting process. Now once the plastic has melted, it would be pushed towards the die, from where it would be coming out depending upon the cross section of the die opening. An uneven flow of molten plastic would produce unwanted stresses in the plastic product. So we have to ensure that the molten flow or the flow of the plastic in the molten stage should be very uniform. So an uneven flow, as is very clearly mentioned on your screen, an uneven flow of molten plastic would result in certain stresses which are completely unwanted, and if these stresses are present in the product, after some time the product may fail because of these developed residual stresses. So these stresses have to be avoided in any case. So these stresses can cause warping after the solidification of molten plastic. Some of the effects are given that if these stresses are present, and these stresses are present because of the uneven flow of the molten material in the plastic product. So these stresses can cause warping after solidification of molten plastic. Plastics are very good thermal insulators, and therefore it is very difficult to cool quickly. So that is another issue that is involved. If you remember the diagram that we have seen for extrusion, we have a separate cooling arrangement after the final product is coming out of the die opening. Now why that cooling arrangement has been provided? It has been provided because of the point which is mentioned on your screen, that is plastics are very good thermal insulators. So when they are thermal insulators, therefore the cooling may take a long time, therefore we can say additional cooling arrangements are provided to cool the plastic products once they are formed. So we have to avoid the stresses, we have to cool the plastic products after they are formed, so that we can avoid the problems or the difficulties later on. So the cooling of the plastic product is achieved by pulling through a set of cooling rolls, water or air cooling, which we have seen in the diagram that there are cooling rolls available after the extrusion process is done. After the product comes out of the die opening, we have arranged cooling rolls arrangement which cools the final product, and the final product is now ready to be shipped or to be put into the warehouse. So basically, important point to note here is that there are certain additional attachments in the process, or certain additional equipment in the process which helps us to achieve a better quality product. Now the contaminants can be arrested, the cooling can be done, and there can be other attachments which may further improve the efficiency of the process. But the basic process is that we would be melting the plastic inside the barrel and then pushing that molten plastic through the die opening to get the final product. So we will see some of the other important details related to the extrusion process. Like on your screen, you can see the process parameters. Now what are the important process parameters that have to be taken into account specifically in case of extrusion of plastics that we can see? Melting temperature of the plastic. Why? Because we have to design the heating elements around the barrel in such a way so that we are able to generate the specific temperature required to melt a particular plastic material. Now suppose the plastic material does not melt properly, the feeding through the rotating screw would also be problematic. We may not be able to get the desired viscosity, and sometimes some unmolten or unmelted solid pellets may be formed in the final product, which may act as concentration points where the failure may take place. So important point is that one of the important process parameters in case of extrusion process is the melting temperature of the plastic. So before subjecting any plastic material to the extrusion process, we should definitely understand the melting characteristics of that particular plastic. Second important point is the speed of the screw. Now the speed of the screw should not be very fast and it should not be very slow. So an optimal speed of the screw has to be adjusted so that the general behavior of the polymer melt is such that it is able to come out of the die in the best possible or in a good quality product. If we do it very fast, there can be certain types of defects that may be present or prevalent in the products being made out of the extrusion process, specifically in case of plastics. And if it is very slow, there also there may be certain problems related to the quality of the final product. So, two important process parameters are the melting temperature of the plastic and the speed of the screw. Third important point is the extrusion pressure required. Now, I have already told in case of extrusion, screw type of extruders are very common, in which a rotating screw is used to feed the molten plastic towards the metering zone into the die, and from the die we get the final product. Now, this screw feeder, how much pressure should the screw feeder apply on the molten plastic is very important. So, the extrusion pressure required to form the shape of the final product is also very important. Now, the types of the die used is also equally important. Last is the cooling medium. Now, in the total extrusion process, once the final product comes out of the die, it has to be cooled, which was very clearly explained in the previous slide also, that cooling is definitely required in case of processing of plastics. So, therefore, the design and type of the cooling medium also has to be understood in case of the extrusion process. Now, what are the important points that have to be taken care of specifically in case of the extrusion process are, or what are the important process parameters that have to be accounted for in the, we can say, good quality, high manufacturing or high production rate extrusion process are: we should be able to control or monitor the melting temperature of the plastic, we should have the information about the optimal speed of the screw, we should know what is the extrusion pressure required for a particular plastic, we should know what type of die has to be used if we want to get a particular shape, and finally we should also understand that what would be the type of cooling medium that would be used when the product would be coming out of the extrusion and would finally be cooled. So, it is easier said than done that the extrusion is a very simple process, because an exact control of all these process parameters is very important, and if these process parameters are not controlled properly, then the product that we are going to get out of the extrusion process will not be of very good quality, and there can be different types of defects that may be found in the final product which is coming out of the extrusion process. So, again I would like to revise or read what is already written on the screen, that is the process parameters or the important or the critical process parameters in case of the extrusion process. Now, the important parameters are the melting temperature of the plastic, the speed of the screw, extrusion pressure required, types of die used, and the cooling medium. Now, these are the important points that have to be taken into account. Now, the screw design is also very important. Why? Because it is the element which is applying or which is exercising pressure over the molten plastic and feeding it into the die, so that it takes the shape of the die and gives us the final product. Now, screw design, the rotating screw has three important functions. Now, what are the functions of the rotating screw that have been highlighted on this particular slide? Feeding, it has to feed the material. When the material is falling under the influence of gravity from the hopper into the barrel and it comes in contact with the rotating screw, what is the first function of the rotating screw? The first function of the rotating screw is to feed the raw material, that is the pellets, towards the melting zone. So, first important point is the feeding of the raw material. Second important point or function of the rotating screw is to ensure uniform melting and mixing of the plastic. So, the second important function which a particular rotating screw in case of extrusion process has to satisfy is that it should ensure uniform melting and the mixing of the plastic. That is the second zone, that is the melting zone, and finally it generates the pressure to push the molten material through the die. So it has to ensure feeding, it has to ensure melting, and it has to further ensure that it has the pressure to push the molten material, or it generates the pressure to push the molten material towards the die, and from the die finally a product comes out. So the rotating screw has three important functions which I would again revise. It is used for feeding, it ensures uniform melting and mixing of the plastic, and finally it generates the adequate pressure to push the molten material through the die into the final product. Now different zones in the screw length, because if you remember the diagram, there was a definite length of the screw. Now this particular length can have different zones. There can be a feed zone, there can be a melting zone, and there can be a metering zone, which we have already discussed. Now we come on to the types of extrusion process. So there are different types of extrusion process. One by one we will try to understand at least one or two of these processes. The different types of extrusion process are, it can be broadly classified into the following types, that is sheet film extrusion, blown film extrusion, over jacketing extrusion, tubing extrusion, co-extrusion, extrusion coating, and compound extrusion. So different types, different names have been given, but the basic principle is same, that the molten plastic is formed into a given shape as it passes through the die. Now some of these we will try to understand with the help of some text and some diagrams, but important point to note is that the name, from the names itself it is very clear that these processes have been developed for specific application requirements. As the very first process on your screen you can see sheet film extrusion. So sheet film means that the final product would be in the form of a film or a sheet. So we can read what is there on the slide. The molten plastic is extruded through a flat die. So as I have already told, the final product or the shape of the final product or the cross section of the final product would be dependent upon the shape of the die. So in case of sheet film extrusion, the die would be a flat die. So the molten plastic is extruded through a flat die. The cooling rolls are used to determine the thickness of the sheet film and its surface texture. Now if we want a specific surface texture or a specific surface finish on the sheet, the rolls can be, or the cooling rolls can be adequately or judiciously selected. So the cooling rolls will dictate the thickness and the surface texture of the film, as it is very clearly mentioned in point number 2. I am reading that point for you. The cooling rolls are used to determine the thickness of the sheet and its surface texture. And where are these cooling rolls? These are at the end of the barrel, outside the barrel. Once the product comes out of the die, it is taken by the cooling rolls. So the thickness of the sheet can be obtained. Some typical range of thickness is given, that is, it may range from 0.2 to 15 millimeter. So a fairly thick sheet can also be made by the sheet film extrusion. The thin flat sheet or film of plastic material can be made. So this is the application area of the sheet film extrusion. Generally polystyrene plastic is used as a raw material in sheet extrusion process. Now one type of a material is given which can be used for sheet film extrusion. The typical thickness range is also given, and the final shape that we can get out of sheet film extrusion is mentioned on this particular slide. Second one is the blown film extrusion. We will try to understand it with the help of a diagram also. The die is like a vertical cylinder with a circular profile. So the die in this case is like a vertical cylinder and it has got a circular cross section. So vertical cylinder, circular cross section. The molten plastic is pulled upward. So it is a vertical forming process in which the shape will be given in a vertical manner. So the molten plastic is pulled upward 4 to 20 meters. 20 meters is a considerable height. So the molten plastic is pulled upward, and the die, how it is pulled upward from the die? With the help of nip rollers. Now what are nip rollers? That we will see with the help of a diagram. So the molten plastic is pulled upward through this die with the help of the nip rollers. The compressed air is used to inflate the tube around the die. So the tube would be inflating around the die, as in the case of blow molding, which we would be seeing at a later stage. Now this compressed air is used to inflate the tube through the around the die. So we have a die and this tube would be, or a plastic tube would be inflated. In the center of the die is an air inlet from which the compressed air can be forced into the center of the circular profile, and hence the creating a bubble. So here we will see how that bubble is formed with the help of a diagram. And finally the extruded circular cross section may be increased 2 to 3 times of the die diameter. So this circular cross section can be increased up to 2 to 3 times. Now let us try to understand this with the help of a diagram. In this particular diagram we can see that we have a molten plastic which is coming down in the vertical fashion like this. The air is entering from here. This is the die, vertical die with a circular cross section. Molten plastic is entering the die and the air is blowing out the molten plastic. This is the air ring. Compressed air is entering from here and from this side also, and this is the bubble which we were talking about. This is the bubble which is formed, and this is pulled up with the help of these nip rolls. So this plastic is being pulled up because of this movement of these nip rolls, and this bubble will go or move up, and at the collapsing plate it would collapse, and finally this is the sheet that we are generating, or the film that we are generating, that is blown film. This is the film, this is the idle roll, this is the lay flat. The final product is called a lay flat. This is the lay flat which is coming and getting wound over the roll. So this is the roll of the film. So basically we can see the plastic is entering. There are two important points to note here, that we have a molten plastic and we have a compressed air and a air supply. Now the air will blow out the plastic, it will give it a form of a bubble shape, and this bubble would be collapsing at the collapsing plate, and finally we will get a sheet of which we may call as a lay flat, and which is called as a blown film. So this is a blown, means from the blown word is coming from the air, because air is being used to blow out the molten plastic. So basically we have a molten plastic, we have a supply of air, the air is blowing out the molten plastic into the forming a kind of a bubble, and this bubble is collapsing at the collapsing plates and it is forming a film, and the film is getting collected on the roll. So this is the process of blown film extrusion. Then we have a jacketing coating, in which we see the adhesion between the wire and the coating is not required. On your screen a very simple diagram, you can see the green color represents the molten plastic and this is the roll of wire. Jacketing means we are jacketing the wire with the plastic. So here we can see this is the roll of wire from where the wire is coming, and this wire we want to jacket around by the plastic. Why? Because plastics are thermal insulators and many of the plastics are electrical insulators also. So in case of electrical wires we can coat them, or we may like to jacket the wire with the coating of plastic material. How it can be done? We can see the molten plastic is coming from two sides, the wire is coming from this side and the wire is moving out. The adhesion between the wire and the coating is not required because this jacketing is taking place outside the die. This is our setup. Outside the setup the jacketing process is taking place. In a different case, that is pressure coating, we can see an intimate contact or adhesion is required between the wire and the coating. Why? Because the coating is taking place within the setup only. From the roll of wire, the wire is coming. If you see the arrow, this is the movement of the wire. Wire is coming from this direction, it is moving in this direction, and the molten plastic is again coming from here. This is the point where the jacketing or the coating is taking place, and finally we get the coated wire outside. So this is also a kind of extrusion process in which we are coating the molten plastic outside the wire, or we are jacketing the wire with the coating of a plastic material. Why it is required, that I have already told. Then we can go for tubing extrusion. Hollow sections are usually extruded by placing a mandrel inside the die. So if we want to make a tube, instead of a solid rod we need to have a mandrel, that all of us know, that is very common in case of tube drawing also. So hollow sections are usually extruded by placing a mandrel inside the die. The molten plastic is extruded through the die and the hollow cross section are formed like the tube. So we can get hollow plastic tubes also by using a mandrel. Tubing with multiple holes can also be made for specific application. Now if we want to make different holes, number of holes of different diameter, different mandrels can be used for specific applications. So here, by placing a number of mandrels in the center of the die, we can make a specific design also, in which number of hollow sections can be there. So tubes can also be made by plastics by the process of extrusion. Now what is co-extrusion? Co-extrusion is the extrusion process of making multiple layers of material simultaneously. Like we have seen in one of the process, that is in which film of plastic is coming out of the extrusion machine or extrusion process. This film can have different layers. Why? Because we require certain specific properties. So in co-extrusion we can blend different types of films together to get the desired properties out of the final product. So co-extrusion is extrusion process of making multiple layers of the material simultaneously. So it is used to apply one or more layers on top of the base material to obtain specific properties. Now what are the specific properties that are desired? These specific properties desired are such as ultraviolet absorption, grip, sometimes we want to have a matte surface, and sometimes we require energy reflection. So the base material is more suitable for some specific applications like impact resistance or structural performance, and the top coating or the top we can be having certain ultraviolet resistance or resistance to ultraviolet radiation, or maybe providing a matte surface, or maybe in some cases only to have a good surface finish also. In co-extrusion, the base material will have different properties, different functions, and a different material may be chosen for that, and on top of that we have other layers which are co-extruded on the base layer, so that the properties of the top layers are entirely different depending upon the specific requirements for which the extrusion process or the extrusion product is being made. Now it may be used on any of the processes such as blown film. As we have seen, in blown film we are making only one film. We can use this different type in which we can have 2 or 3 different layers in the blown film, or in which we are making a plate. In one of the processes that we have seen today, that we can make a plate up to a thickness of 0.2 millimeter to 15 millimeter. So we can have 2 or 3 different layers co-extruded, so that the total thickness has got gradient properties, or we can say the properties are varying in the thickness of the plate. So it may be used on any of the process. In a co-extrusion can be done with different processes like blown film, over jacketing, tubing, or sheet film extrusion. As we have already discussed, in sheet film, one sheet is coming, we can make 2-3 different sheets with the help of co-extrusion process. So 2-3 different sheets would be coming out together in a single form. The final product would be single, but it would have gradient properties in the through the thickness of the final product. So 2 or more extruders are used to deliver the materials which are combined into a single die that extrudes the material in the desired form. The layer thickness is controlled by the speed and size of the individual extruders delivering the materials. So basically different types of extrusion processes can be there. Although we have discussed only 2 or 3 important variants of extrusion, but there can be other variants of extrusion process also. Although we have seen only 2 or 3 important points related to the process variants, that is, we have seen over jacketing, we have seen sheet film extrusion, we have briefly outlined the tubing extrusion and the blown film extrusion. So with this we come to the end of today's lecture, in which we have seen that what is the extrusion of, what are the important points to be taken care of in extrusion of plastics, or what is the extrusion process specifically in context of plastics. We have seen that basically 3 steps are involved, which means heating, forming with the help of the screw feeder, in the form of a die, and finally cooling the final product. And we have seen some of the process variants of the extrusion process. To name a few, we have seen sheet film extrusion, blown film extrusion, we have seen jacketing extrusion, and finally in the last we have seen co-extrusion. So different types of extrusion processes can also be there, but in today's lecture we confined our discussion to these processes only, or these process variants of the extrusion process only. In our subsequent lecture we would be discussing other techniques which are used for processing of plastics. Thank you.